Alrighty, page 3, hyperbolas. Again, we're just going to look at eccentricity for a second. Eccentricity is E, and of a hyperbola, is it equal to the ratio of C over A? And it's going to be, the eccentricity of a hyperbola is going to be between 1 and, that's supposed to be an infinity symbol, so just work with it. If the eccentricity is close to infinity, the shape of the hyperbola will be fat and wide. Or, excuse me, that would be from the Department of Redundancy Department. How about just flat and wide? Okay, how about like really flat and wide, spread out wide? That's going to be your eccentricity of closer to infinity. If eccentricity is closer to 1, then you're going to have one of those narrow, skinny looking branch things like that. Okay? Mm-hmm. All right. Excellent. We are going to skip down to sketching the graph. Let's look at this example here, which is x minus 3 quantity squared over 16 minus y plus 2 quantity squared all over 9 equals 1. You should be able to tell just by looking at this equation that it is a hyperbola. The two big keys, the minus sign and the 1. Okay? Now, just by looking at it, you should be able to tell what your transverse axis is. What's it going to be?
X.
It's going to be, well,
in the X.
It's going to be horizontal,
yeah,
right?
Horizontal.
Okay, so we're good for that. So what we're going to do, that makes this the a squared, right? So a squared equals 16, so what is a?
4.
4. B squared then equals 9, so what is b?
Negative 4. Or
B is
3. Sorry.
That's all right. Negative 4 was my other answer. Go ahead and tell me what my center is, because that's pretty important.
That would be
3, negative 2.
negative 2.
Perfect. Okay, now if you look at the bottom there, it says center, it says vertices, it says foci, it says eccentricity. You want to label things on the graph. How do we find our vertices? Well, let's think about it. If you go back to, first of all, this is a, what do you call it? It's got a horizontal, so remember on that one, your transverse axis, if you look at that, was y equals k. Do you remember that?
Yes.
Okay.
Well, to find out the vertices, you'd use, you know, a comma 0 and negative a comma 0, right?
Or wait,
except my center is not there. Basically, what I'm going to do, let's go ahead and
H plus a comma k, and then H minus a comma k.
let's go ahead and plot our center. I think it will be better if we just start there. What was my center again? It was 3, negative 2. So
yeah.
if I go 1, 2, 3, and then down 2, there's my center. Now, I know that my transverse axis length, or my semi-transverse axis length, is this A of 4. So I can go 4 over to the left and 4 back to the right. And I want to go horizontal because it was under the X here, right? So 1, 2, 3, 4. I can put that there. And 1, 2, 3, 4. I can put that there. And that just kind of gives me part of my rectangle, right? These are actually the vertices right here. Okay, I didn't move up or down, right?
Right.
So my vertices actually lie on this y equals k, so they actually lie on the line y equals negative 2. So my vertices, let's see, my center was at 3, negative 2, so it's going to be at negative 1, negative 2, because I took away 4.
Yep, and then 7, negative 2,
and then
because
7.
you added 4.
Exactly. So these are actually the vertices, okay? But it's also lands on the side of my rectangle, okay? Now, how far up and down am I going to have to go because of my conjugate axis? It deals with this b of 3 here, right? So if I take 3, go up 3, 1, 1, 2, 3, it's going to end up here. If I go down 3, 1, 2, 3, it's going to end up here. And now I just make the rectangle that works with that. If you're satisfied with that.
Absolutely.
Okay, and what that does is it tells me where my asymptotes are going to go. And it's not the easiest or best looking rectangle, but those are fabulous asymptotes. Okay, so I know that this little distance in here was my B distance, which was 3, and this distance from the center here to the vertex over here, is my A. All right. Now, the other thing is I can pretty much go ahead and draw in my branches because it's going to follow the asymptotes. But one thing it asks for that we don't yet have are the foci. And so we need to be able to find the foci. And we're going to talk about that. Okay. We know that the distance from this vertex right here to this center, this whole distance is A, correct?
Mm-hmm.
Well, my foci is in here somewhere. And the distance from the focus to the center is C. So we have to use that little formula in order to come up with what C is. So if you'll remember, C was equal to the square root of A squared plus B squared in this case. So C equals A squared was 16, B squared was 9. C equals square root of 25, right?
Mm-hmm.
So C is what? 5?
Mm-hmm.
Okay, so let's look at where the focus would be. Where would it be? Where would this one be? It's going to be 5 over, right?
Yes.
So it's going to be inside there, just 1,
Okay. Yeah.
right? And it would be 5 away from here, so it's going to be inside here, just 1. So the actual point of my foci would be -2, and 8, -2. That would be where the foci are located. And I got that by adding the C distance to the center, to the H, and subtracting the C distance from the H. Are we okay with that?
Yes.
All right, the last thing it asks for is eccentricity. And what is eccentricity? Eccentricity is C over A. So what do we have? C was
5.
5,
Over A
A
equals
is
4.
4, so that's about 1.25. So that's obviously closer to 1. So this is going to be narrower and skinnier than the flat and wide. Okay, even though it doesn't look hugely, I mean, you can have them that you can't even tell it's a hyperbola because it's so flat and wide.
Okay.
Do you see what I'm saying?
'Cause mine's pretty fat.
Well, it's not huge fat. I guess it's kind of like if you think of a line being, if we look at our parent function, right? If you look at your parent function of a line, well, if I were just looking at the line and I know that that's like 45 degrees, I might just think it's steep by looking at it, but I compare steepness to that.
Okay.
So this is pretty close to, you know, not the skinniest, but
Would an easier way to look at it be to see if the asymptotes where the hyperbolas are more acute or obtuse?
you just want to look at the eccentricity. It's
Okay.
actually just closer to skinny than it is to the flat and wide.
Okay.
But what you want to know, what's kind of cool is we could have a similar looking rectangle, and you just need to be careful when you graph it, because you may have the rectangle graphed and forget which one's your vertice, and you may graph it wrong. So you want to be real careful to check your original equation to make sure that you're drawing your branches in the right way, because you might go to all the trouble to get the box and the thing and then put your branches on the wrong one. Do you see what I'm saying? So you got to be real careful with that.
Yeah.
All right? Okay, we'll kill the thing.